Introduction. Queuing theory is the study of how line forms, how they operate, or how to manage them effectively. It helps to analyze situations where people or things wait for service, like customers in a grocery store or cars at traffic light. We have decided to do our queuing project at Kenangan Coffee. The location of Kenangan Coffee that we have chosen is P16G, Jalan Prima 1, Pusat Komersial Bentong Prima, 28700 Bentong Pahang. The operation time of Kenangan Coffee during weekdays is from 8 AM till 10 PM, but during the weekend, they open a bit late, which is 10 AM till 10 PM. We do our observation at 12:13 PM till 1:40 PM. During the observation, Kenangan Coffee only have one server.
Next, characteristic of a queuing system at Kenangan Coffee Bentong. The first characteristic is arrival time. The size of the calling population at Kenangan Coffee Bentong is unlimited or infinite because it can attract anyone from the surrounding area or beyond, with no restrictions on the number of people who can potentially visit the cafe. Second one is the pattern of arrival at the system for Kenangan Coffee Bentong follow the Poisson distribution. For example, the average number of arrival per hour, which is lambda, is 10 customers per hour. And the last one is the behavior of the arrival is patient customer. Customer wait in the queue until they are served. Second characteristic is waiting line. The length of a line is unlimited or infinite because it has no endpoints. The second one is queuing discipline at Kenangan Coffee Bentong is first in, first out FIFO. It means that the first customer who arrive is the first one to get served. Third characteristic is service facility. First, number of channels. Kenangan Coffee has single channel system which is one server only. Second, number of praises is multi-praise system because it has 2 stops before leaving the system. Next, the pattern of service times at Kenangan Coffee follows the exponential distribution. For example, average number of customer, which is mu, is 13 customers per hour. Now, let's take a look at the basic queuing system configuration. For Kenangan Coffee at Bentong, it is single channel multi-praise system. It means that when customers arrive, they will place an order. Next, they will proceed to the service facility where their order will be taken and a queue number will be given. After a few minutes, their queue number will be called and the customer will proceed to take their food. Once all these steps are completed, the customer will exit Kenangan Coffee.
Based on the data collected at Kenangan Coffee, arrival rate lambda is 10 customers per hour and the service rate mu is 10 customers per hour. Firstly, we calculate the average number of customers in the system, which is L equal to lambda over mu minus lambda. By substituting the value of lambda is 10 and mu is 13 in the formula, we get 3.3333, which equivalent to 4. Next, we calculate the average number of customers in the queue, which is LQ equal to lambda square divided with mu multiplied with mu minus lambda. By substituting the corresponding value, we get 2.5641, which is equal to 3. After that, we can calculate the average time a customer spends in the system, in which W equal to 1 divided with mu minus lambda and get 0.333 hours, which equivalent to 20 minutes. Next, we calculate the average time customer spends waiting in the queue, in which WQ equal to lambda over mu multiplied with mu minus lambda, and the result is 0.2564 hours, which equivalent to 15.4 minutes. We continue our calculations by finding the utilization factor for the system, which is the probability that the server is busy, by dividing lambda with mu. By substituting the corresponding value, we get 0.7692. We can also know the probability of no customers are in the queuing system, or percent idle time, which is PO equal to 1 minus lambda over mu, and get 0.2308. Then multiply with 100 to get value in percent, and the result is 23.08%. I will show you how to solve queuing system using QM windows. Firstly, open your QM window, and in the left section, you will see waiting slash option and click. Then click M/M/1 exponential service time. Since our QM system is single channel, you can enter the title and the cost analysis remain none and click OK. For this part, you can change the time unit, and for our group project, we use hours. And you can enter the value lambda and mu. And click the button solve. On this solution, you can see the average server utilization is 0.77, LQ is 2.56, L is 3.33, WQ is 0.26, and W is 0.33.
In conclusion, this study looks at queuing system at Kenangan Coffee with one server and how it affects customer waiting time. The server worked efficiently, handling 13 customers per hour, while 10 customers arrive each hour, meaning it is busy 76.92% of the time. On average, customers spend 20 minutes in the system with 15.4 minutes waiting in the line. The single server is enough for the current demand, but the waiting time might be too long for some customers, which could lower their satisfaction. To make customers happier or handle more demand in the future, adding another server or improving the process might be needed.